um, the initial title of this presentation was How to Derail a Train. So I have to admit, I went through 5 different decks to actually present this morning. So I'm a little bit mixed up. And the title changed a number of times, so the title of the presentation is slightly different than what it is announced, but in essence, we're covering the same topics. So this morning, since we're here to learn how to derail a train, basically this is an awareness presentation. I want to make sure that everybody out of here understands that there's criticality in our national infrastructure. I'm from Canada, Montreal, so bear with me with the accent. But we have the same problem in USA and in Canada. So let's talk about this. Hopefully the FBI or the NSA is not going to wait for me and allow me to catch my plane. So if we're to derail a train, where do we start? Certainly not with pennies. It is a misconception that you put a penny on a track, it will derail a train. It doesn't work that way. So basically, a train is a number of subsystems. A train system is a number of subsystems, such as tracks, rolling stocks, human beings, and digital control systems, and which is where we're heading with this. So in the USA, there is a number of bad lines, so that would be one way of derailing a train, is just let it go and don't take care of it, don't maintain it, and your train will end up derailing. The Penn Station, New York, has a very, very complex switching mechanism for all the trains coming in and out, and all of this is under digital control, and we will actually touch on this in a few seconds. And human factor is also a consideration, so it must be pretty boring to drive some trains on very long distances, so it is often that the drivers will fall asleep. It is a known fact. So let's talk about some of the major weaknesses of a train system. First of all, it is an ICS system spread over hundreds of miles. So many of the components are isolated between each other. They use simple electronics. So a train company is rather slow in going towards new technologies. Because it works, we're just going to leave it this way. We're not going to change it. And they're very slow at accepting standards. But in essence, it is a standard ICS network. There is no real cybersecurity standards associated to this national critical infrastructure, believe it or not. So we are actually relying on existing standards, and there are some flaws. I will highlight that in a few seconds as well. And as we've seen with 9/11, terrorist groups are setting to actually hit eventually track infrastructures here on US soil and in Canada. Why? Because it would be maximal social impact and major financial impact, because once a line is actually hit, all the traffic on that specific line is actually stopped, and therefore we're not delivering the goods, we're not delivering the people, and that's pretty major financially as well. So I'm not going to bore you too much with track systems, because in essence what we're talking about really is ICS, but just so you know, there's 100,000 miles of track on what we call Class 1 railroads in USA only. That's 500, that's 500 million passengers yearly, 6.4 billion miles made by passengers, and 1.6 trillion miles of freight. All of this is under the happy maintenance and the good high of 150,000 happy employees. And you see where I'm going with this. So before I move forward, I'd like to introduce who we are at SNC-Lavalin. Some of us know us as Atkins as well. So through an acquisition, SNC-Lavalin and Atkins joined hands and is now the same company. I'm part of the Global Rail and Transit Group. So basically, we are a small construction and engineering firm with 50,000 employees in 50 countries. Again, our group is rather small, where there's 6 of us in cybersecurity just for train and transit. We do end-to-end rail and transit capabilities. So we build either greenfield, new tracks, new trains, new transit systems, or we overall existing railways. Anything from capitalization to consulting to building the physical track and procuring the rolling stock material on it. And we do systems integration and insurance, and we even go as far as operating and maintaining some of these lines. And we do it on all type of railway systems, whether it's light rail, main line, freight, high speed, and whatnot. Who am I? So I'm an aeronautical engineer. So what am I doing on stage here talking about trains, where I should be talking about planes, right? So I work with the Canadian Space Agency. I've done lots of robotics design in my life. I've done about 20 years of 3D manufacturing as a software matter expert at Autodesk. I've been programming since 1984. That's over 30 some years. And I'm also a social entrepreneur. I've built a number of tech companies and sold them to other larger entities. So I've been around, and what I'm about to tell you today is really all related to this baggage that I've been carrying around. I've mentioned that, you know, I've been hacking stuff together at some point today. And so what is a hacker? Well, there's a lot of cliche. If you just Google hacker, you'll see those guys with black hoodies. I'm not wearing a hoodie. What a hacker is, really, it's an inventor. It's a creative person that will take a number of existing things and just make them work together. And some people will focus on digital systems and taking pieces of codes and repurpose it to either with bad goals or good goals and intentions. But really, you know, we shouldn't be suspecting people with black hoodies, really. What we should be suspecting is those 150,000 happy employees. All of these employees are very well paid. They don't have any problems in their lives. They don't have to put their kids to private schools. And, and none of their kids need to have dental works done. So that's our unusual suspects in this session. Human factors, according to a 2017 survey, is basically, I've done some maths for you guys to make this simpler. It's about 38% of employees related attack vectors, right? Such as insider threats, hardware threats, social engineering, accidental loss of hardware, carelessness. So again, awareness is the key impact to reducing the risks in cybersecurity. But again, who would do this? Who would attack a train, or who would attack a critical infrastructure? So we used a 3-circle Venn diagram, and I took the liberty of putting maybe the stereotypical attackers. So somebody with lots of time, or somebody with lots of financial resources, or somebody with lots of knowledge could all be potential threats to an ICS. But actually where it gets quite scary is when these circles converge together and create these zones. And these are the person or the groups that we need to keep an eye on. But we're really here to talk about train and train cybersecurity. And basically, as I said, a train system is really a big ICS spread over hundreds of miles. So we do use a Purdue model with our own flavor at SNC level, and we think that most people we engage about cybersecurity think that it's an IT-related matter, while it's not. So we've actually overlaid an iceberg and said, well, okay, level 4 and 5 is what you see, but actually below the waterline is where the risk is. And if you look at the ISA 62443 or these standards, typically they will start and they will cover situation and scenarios from level 2 and up. So level 0 and 1 are not touched or hardly any, are not touched at all. So let's move forward with this great example here. A number of years ago, about 4 years ago, a group in Germany has decided to create a honeypot scenario. A honeypot scenario is you make something attractive on the web and you wait for hackers to attack it to see what's going to happen. So what they've done is that they've built literally a train signaling system using a model train, but real PLCs, a real network, a real website, real HMI, firewall configured properly, and they've put an analysis tool to do this onto it. So believe it or not, within 6 weeks, they had 2.7 million attacks on that new train line. 250,000 attacks reached signaling modules. So what this says is that no matter how well you're protected, there are people out there that are just looking for fun even to attack and derail systems. So in the report, they've actually created this false breaking news image where basically attackers were able to tell people on the roads that no trains was coming. They weren't warning people properly, and the train actually collided on a truck. So again, this experience was conducted in a relatively modern system, and again, I'm hitting on that nail. The actual system out there are old, and it's pretty hard to actually modernize them, right? Because you have to stop your processes, and you have to replace equipment, or you have to add new software. You need to test that software in a pilot phase. So it's pretty hard to do it within the confines of 4 walls of your manufacturing building. It's even tougher on hundreds of miles. So let's get to the subject matter that really concerns us is level 0 and level 1 attack. So take, for instance, a typical PLC installed anywhere in your buildings or a building management system, train control system, but whether it's on your manufacturing line, we don't really care. A PLC is a PLC. Then invest $40, buy an Arduino module, which they actually train kids in school now to program those. Connect it to your PLC, to a USB port, or through an RS-232 port. Add to this Arduino what we call a communication module or shield, which is basically a cell phone that can talk to your Arduino. And basically what you end up is this real-life example while opening a sidetrack cabinet that was controlling signals again, and this is basically the image that you will see. So most PLCs, considering that they have open USB ports, and by the way, USB ports, you say, yeah, but you know, when you plug a thumb drive in there, the system will detect it. We have systems that will detect that. Well, guess what? When you plug a new keyboard in your computer, does it tell you that you've plugged a new keyboard? No, because the OS is made to not detect necessarily. It will actually take in the input from a keyboard, but will not tell the user or tell any other system that a new keyboard has been plugged in. So any PLC with a USB port, if you plug a keyboard in it, you could, in most of the PLCs still have default password, believe it or not. We see that all the time. So with default password, you could have a ghost typer really remotely connected to that PLC, and using a cell phone, literally inject new commands and new code into your PLC with such an Arduino modules, or what we call a rubber ducky, also another tool that you find on the web for about $30-some. Knowing that most PLCs are not monitored, so a simple Arduino module like we found on one of the boxes that we maintain, you know, sending serial commands, doing ghost typing, changing inputs and outputs at terminal level, acting as man in the middle, and worst of all, reporting all system is okay to the SCADA system back home. So this is pretty scary. Case study number 2 is this new wave of digital connected sensors that are connecting automatically to the cloud The unfortunate aspect of this is that they're notorious for leaving ports open on the internet. It's actually a key selling point for them. But in essence, if you report this back to the Purdue diagram, what it tells you is that it makes a direct connection between the web and your level 0. So therefore, bad guys can use the input coming from the web and control your level 0, 1, and even 2 or 3 directly from the web using a single sensor that's been left connected to the web. So again, there's no standards or hardly any standards for connected sensors to this point. There's many documented exploits as well, which is pretty scary in itself. Another thing that we're seeing in our industry, but I'm pretty sure that it's widespread, is going for cheap. So, we have 500 PLCs to replace, or we have 500 sensors, temperature sensors, so they're just temperature sensors, so we're not going to pay a fortune for them. We're just going to get them from somewhere else in another country because they're half the price. Well, guess what? These sensors come in with electronics on board. They can actually come in with communication systems on board. They can come in with vulnerabilities. And we've seen this on an actual line where they've replaced just a humidity sensor. They just wanted to know if it's raining on that portion of the train line in order to adapt traffic. But these humidity sensors were like the Arduino-based systems, literally connected to the network, and were actually able to be injected remotely by USB, not USB, but Bluetooth, directly by any kids going around with a cell phone. So that's pretty scary as well. And standards in different countries don't necessarily match our standards. So sometimes our standards are higher than they might be in other countries. So that's something to consider. And ultimately, if you report back to, if you remember that Venn diagram, you don't know if that private corporation is not after you, or if the controlling government of that country is not also planning to eventually use all these access points into all of the network. So all 3 case studies I've seen personally in 6 months working with SNC-Lavalin. So this is a pretty scary scenario, and this is really, again, an awareness pitch here. So if you think that your data is worth money, actually controlling your whole industry or your whole line or your whole process is actually worth even more, and it's worth more for outsiders. There's a number of standards in there, and unfortunately what we hear out there is that, we're following such standard, and we're following such standard, and it's great. However, level 0 and 1 needs devices, they need more attention. So considering 62443 doesn't consider smart instrumentation today. They address systems only, they don't address 0 and 1. So the concept of smart instrumentation can actually skip levels and are not considered at all. So again, this needs to be revamped. There will always be cybersecurity gap in the standards. So the standards are actually creating cybersecurity gap because the standards lag on new threats and successful attacks, and they lag on the technology by itself. So, oh my God, what can we do? So my pitch really is awareness, awareness, awareness. Making those 150,000 employees happier is the first step into making this a safer environment. In an ideal world, then develop also an ICS cybersecurity plan or policy on all your device level 0 and 1. Make sure that your personnel is competent and understands what it means. So training is quite important as well. And in an ideal world, and I've met a number of the proposals out there and the companies out there, and some of them actually have a cybersecurity assessment program now for level 0 and 1, which is great. So go and speak with them. That's probably the best thing I can suggest for you. So I thank you for your time. I'm noticing now that I either spoke too fast or I'm missing about 20 slides. So tell you what, I have an anecdote for you. I need to pull this out of my bag. So points of reflection I've heard here since yesterday. Noted. So this is real stuff that I've heard people talk about here, and I'm just here to make fun of it. So we have cybersecurity, however, it's a 9 to 5 watch. So this business has cybersecurity, but the guy works 9 to 5. If something happens in between 5 and 9, then there's no cybersecurity. Another one told me, oh, we have a pager. We have a pager number, so we call there and the guy comes up. So, okay, 2019. You know, okay. We're talking a lot about cybersecurity in our business. Good for you. Heard from the Admiral this morning. Good luck holding up to China. Yep. That gets your gears going. Oh, we have a cybersecurity product. We have a cybersecurity product. Well, cybersecurity is not a product. It's a process. It's a mindset. It's the same way that you just don't go off the street running to cross the street without looking both ways. This is in our building. We were taught when we were kids to do that. We should teach our kids about cybersecurity. It should be the same. Don't put your hand on a stove because you're going to burn yourself. Then don't just plug in any USB drive into anything without assessing, at least at the very little, what it is that you're doing, right? We have security guards. That's pretty cool. Good for you. What are they watching people coming in the parking lot? Good. That's a good cybersecurity measure. Oh, we're a member of an ISAC. Good for you as well, but what kind of good does that give you about cybersecurity? And that's another one from the Admiral this morning. Never let a good crisis go to waste. So learn from the mistakes, but at least try to find ways to detecting those mistakes. So heard this morning and yesterday. Those are gems. I will probably post them in a blog at some point. So thank you, ladies and gentlemen. I will be happy to take any kind of questions that you may have. And hopefully you're not too disturbed about me telling that the rail system, which is one of the best ways of transportation, is actually pretty scary at this point. But good luck. It's good for you that I didn't talk about the aircraft industry.
Thank you, Patrick. My name is Mark McCullum. I'm with ExxonMobil.
Yep.
And so I'm kind of curious from your perspective, certainly with the train industry, similar risks on how things can go bad with injuring personal or human health or whatever. With industrial control, it seemed like for a longest time, we weren't connected, and now we are. And then people say, well, I'm not going to go to the cloud, and now we're starting to see data get to the cloud. And then people would say, well, I'm not going to do control from the cloud, but then there's starting to be applications from that. I'm just curious from your perspective, with your background and in the train industry, if you're in more of a mindset of how do we enable this functionality that seems scary but do it in a secure way, or do we say, nope, this is too scary, we're never going to get there?
It's a great question. So I told you somewhere in the presentation that I sold a number of tech companies that were all cloud-based, and those tech companies can actually provide you with cloud-based cybersecurity if they are aware and if they do take a good approach on cybersecurity. Like in my company at DasBox, we actually have 3 patents on using blockchain technology, literally between our cloud and the devices that were. So it was a company where we built industrial IoT devices. So I was one of the bad guys with those connected devices there. But in essence, we had a blockchain for IoT patent. so that everything is controlled and nobody can actually intercept the messaging. However, when you think about it and taking 2 steps back, our cloud was on Azure. We don't know what employees are actually working there, right? Even though if we want it to be cyber secure, it's very, very hard. So since I've been working with SNC-Lavalin, I took like 3 steps back into the conservative approach. And I'm thinking that in order to, and I kept on being told by the engineers and the comms engineers and communication, and the track control systems guys that, oh, it's a closed network. Don't worry about it. It's a closed network. No, nobody can actually get in. And after 15 minutes visiting a project, I was actually able to take a USB drive and just plug it in a number of places during the construction process. So I said, okay, no, guys, you know, connected stuff is not the best way to approach cybersecurity. Cloud-based stuff, and I'm probably gonna tomatoes thrown at me, but cloud-based stuff, I would actually stay away, but that's my perspective. And take a little bit more of a conservative approach and lock the cabinets, make sure the screws are headless screws that nobody can actually take off, block all the ports, remove USB capabilities from any devices if you can, and have your security guard stand next to whoever supplier that will come in and patch the devices. Unfortunately, nowadays, they will say, yeah, we'll guarantee our product if we can patch it remotely. In some systems, you know, I'd rather pay more, buy a flight ticket and have the guy on site where I can keep an eye on that person. So yes, I took a few steps back towards conservatism and steer away a little bit from the cloud industry, because even if you have the best practices in your company, that cloud is still someone else's computer and you don't know what's on there. Right. Any other questions? Oh, that was easy. Or you all scared? So again, you know, I've been talking about trains, but trains is just a big ICS as well. So what I've said today really applies to just about any other platform. So at SNC-Lavalin, we also help our teammates secure nuclear plants, oil rigs, oil plants, power grids, and whatnot. So our approach is the same, whether we do train in transit or any other things as well. So feel free to come and chat with me. I'll be around until tomorrow. All right?
I have a quick question for you. Can you talk a little bit about the maturity level at the ICS? What your perspective? Are we kind of just the beginning of the infancy stage in terms of cybersecurity, or in the middle, or where do you think we are at?
We're pretty young, I can tell you that. We're pretty young, and I don't think the issue is more ICS related, but actually cybersecurity related. You know, we hear that bad things happen at all levels, even at the IT level, so level 4 and 5. To this point, a lot of stupid things happen because employees are just happy and friendly, and they let anybody do all sorts of bad things without knowing, right? So I have a little anecdote for you guys. So I come from the aviation industry, and in my aviation history class, like 30-some years ago, they were telling us about placards. So placards are basically the little signs that they put on the dash of the aircraft and anywhere on the aircraft. And part of the history of the placards is that there was a point in time when aviation was becoming very popular. They were all propeller-based aircraft. And people were so used and unaware about safety that they would walk in literally into a rotating propeller on the ramp. You know, they're fuel people, the engine is running, they just walk, hey. That's pretty terrible. So what they did, instead of advertising on the web, because there was no such thing as a web, or doing employee trainee, they literally wrote placards in plastic things that they put on the dash of the aircraft and sides of the engines and say, watch for rotating propellers. And this actually started to raise awareness to a point where employees on the ramp said, oh, yeah, that's right. So I should be a little bit more careful. Just this extra level of carefulness will actually save my life. Well, what about we put a placard on our computer screens? It's like, don't let anyone close to your computer. Don't let anyone plug a USB drive in your computer. Watch for this, watch for that. Maybe that's a way of raising awareness. So again, to answer this gentleman's question, I think we're still at the infancy stage of cybersecurity awareness itself. And the more people across all levels of the Purdue diagram are aware, whether they're plant employees or somebody working at the head office, we should all be aware that just don't accept phishing email. Well, you don't know it's a phishing email, but if somebody sends you a picture of a cat and it's not solicited, don't click on it. Don't open files if you're not actually expecting it. And to this day, I'm still getting a number of files from colleagues within. Some of them are jokes, fake calendars, PowerPoint presentation to talk about the play that they will be playing in next week. It's all stuff that could be infected. So my response to this is, sorry, I did not ask. Sorry to be brutal, but I did not ask for that PowerPoint. Did you actually send it purposefully, or is it a phishing email? And typically the person will say, oh, I didn't realize. Thank you for telling me. I will not do that ever again. But yes, by the way, the PowerPoint is legitimate. So again, awareness, and that is across all levels of the Purdue model, even on the floor. And the floor is actually worse. This is where you get the calendars of sexy girls, fast cars, screensavers that they install on HMI machines just because they find it more joyful. So again, we're still very young and immature as far as cybersecurity. And I think that it begins at that level. You can hire the best cybersecurity people, sell you a product or a pile of paper or a nice binder with this thick of a policy. First of all, nobody will read it. And it will never be implemented properly. So training, awareness, I'm not going to say it enough, but that's the key for me to cybersecurity. Thank you.